Hey there, grade six. Today we are going to be looking at comparing fractions and decimals. And so, as we've been talking about, we're going to talk about some learning targets, and there's only one today. And the learning target for this lesson is that I can use fractions as benchmarks to compare other fractions or decimals. Um, then there are some skills that we sort of need to know before we get started or get through this stuff together. And the first one is I need to be able to put decimals and fractions on a number line. I also need to recognize numbers with up to 2 decimal places, and then also recognize their equivalent fractions, both proper and mixed. So that's what I need to know. So here's where we're going to start. I've drawn out two number lines. One of them, the one on the top, is divided up into tenths. So we can see it goes from 0 all the way up to 1, and it goes 0.1, 0.2, 0.3, and so on and so forth. The second one that I have drawn out is basically it's a number line that's divided equally in half, and I've drawn out or written out the word half. And so the question there is, do we notice anything about the two number lines at all? And hopefully the first thing that we notice is that 1/2 and 0.5 are like right above each other, or right in the same area as each other. And so what we need to recognize is that 0.5 and 1/2 is that they represent the same value. There is an equivalency to them. And so we can start using this simple number line to start comparing decimals to fractions. And we can say, well, what about 0.2? How does it compare to 1/2? Is 0.2 greater than or less than 1/2? And well, we can say that 0.2 is going to be less than because it's further to the left than 1/2. We can say something like, 0.7 is going to be greater than 1/2. And so we can start using decimals and fractions and sort of start comparing them to each other. It's still sometimes useful to have them in the same equivalency. In other words, both as fractions or both as decimals, but you should be starting to be able to see, that we can use 1/2 to say, well, there are certain decimals that I know are less than 1/2, and certain decimals that I know are bigger than 1/2. And so that's where we're going to start with or keep going with our stuff today. So what we're going to do now is we're going to use some other common fractions to compare decimals. And the instruction here says, well, let's put 1/4 and 3/4 on this number line. And so 1/4, I'm going to put right here, because 1/4 is actually right there. It's halfway between 0.2 and 0.3. And then I'm going to put 3/4 over here, because it's halfway between 0.7 and 0.8. Now, if you were to make your own number line and have it all divvied up between 0 and 1, and you were to fold the 1 over on the 0 and have those two parts touching, that first fold point would be right at 1/2. If you were to fold that a second time, so you would fold 1/2 over to 0, that fold line would be right there. That would be 1/4. And likewise, if you were to fold 1/2 over to 1, that fold line would be for 3/4. And so that's where those two fractions will fall. Now, so it's helpful that we can start using the number line to visualize some of the comparison questions that you're going to look at in your workbook. And so what I mean by that is, if we see something like, 0.8 and 3/4, and we say, well, which one is bigger? If I were to use the greater than, less than, or equal symbol, I would have to say then, because 0.8 is further to the right than 3/4, I would say that 0.8 is actually bigger than 3/4. I don't even need to convert 0.8 to a decimal or convert 3/4 to a decimal. I can just look on the number line and figure that out. Likewise, if I had something like, I don't know, let's say if I had something like 0.2 and 1/4, and I wanted to figure out which one was bigger, I could again look at my number line here and say, well, 0.2 is further to the left than 1/4. And if a number is further to the left on a number line, that means it's smaller. And so here I would say that 0.2 is less than 1/4. Now, you might start asking, well, what about hundredths? What about numbers with 2 decimal places? And so I should probably make that a little clearer here. And I have my number line, and it's actually divvied up into 100 little sections. There we go. And then I've also put on we're calling our benchmark fractions, right? So 1/4 goes right here, 1/2 goes right here, 3/4 goes here. Now, just to be real clear, 1/4 is drawn at 0.25. 1/2 we see is drawn right at 0.5. I'm just going to push this up a little bit. It's at 0.50, and then 3/4 is actually right at 0.75. And those are sort of the decimal equivalents of 1/4 and 1/2 and 3/4 for our benchmarks. But then we can start saying like, okay, what about like 0.22 versus 1/4? Well, 0.22 is like right here, if I count over 22 spots, and it's still a little bit to the left of 1/4. And so I still can say that 0.22 is less than 1/4. Or if I get, if I say something like 0.68 and 3/4, I know I'm getting a bit squished in here. 0.68 and 3/4, 0.68 is around this area, probably right about here, I think. And again, it's to the left of 3/4, so I can say that 0.68 is less than 3/4. So again, it's nice to have the number line all divvied up properly so that we can visualize some of these questions. What we want to be able to move on to, though, is to just look at a question and say, well, I can look at that and I can know that, or I just know that this decimal is greater than or less than this fraction, just because I know where they would roughly be on a number line. And so that gets us to this last part where we start thinking about comparing numbers to help find equivalent fractions and decimals. And so what I've done is I have written out a half. I drew out a hundreds grid. So these are 100 squares that are, they're fairly equally spaced. I try to make it as clear as I could. I don't know if you can see that this line here is a bit thicker than the rest of the lines. And so I colored all of this stuff to represent half of this square is colored in. Now, if I know from previous videos that one of these whole rows colored in represents 1/10, and I have 5 of these whole rows colored in, then I know that that can represent 5/10. I also know that because I have 100 squares drawn out here, I have 50 of them written out. And so 1/2 is equal to 5/10, which is also equivalent to 50/100. Now to convert from 5/10 to a decimal, this is 5/10, so this is 0.5. This is 50/100, which ends up being 0.50. Numerically, what I'm saying here is that if I have a half, I can use my scale factors. So if I multiply 1/2 times a factor of 5, that's going to give me 5/10. If I have a half and I multiply it by a factor of 50, that's going to give me 50/100. And so that's going to help me find equivalent. Knowing the scale that I'm going to be increasing the fractions by is going to help me figure out other equivalent fractions. And so the next one I have written out here is 1/5. And again, I think you can kind of see it on the video on the screen that these lines here, what I've done is I've divided this 100 block into 5 equal sections. And so I want one of those sections colored in. So I'll just do that real quick because this video is getting a little bit long. So that's one of those fifths. And now what I've done is I've colored in 2 whole rows. And I know, again, one row is 1/10. So if I have 2 rows, I have 2/10. And then if I think about it in terms of 100 little squares, I have 20 of those little squares colored in. And then again, my 2/10 is 0.2. And then 20/100 converts to 0.20. Now numerically, to show you, to find the equivalent fractions, if I start out with 1/5, I'm going to multiply it by a factor of 2. So 1 times 2 gives me 2. and then 5 times 2 gives me 10, so I can show here that 1/5 is equivalent to 2/10. Likewise, if I have 1/5 and I multiply it by a factor of 20, then I get 20 over 100. So again, showing that 1/5 is equal to 2/10 and that 1/5 is also equal to 20 over 100. So that's going to come in handy in just a second as well for our last thing here. Sorry. The last thing I want to show you is comparing fractions to decimals using equivalent decimal fractions. And so I'm actually going to do this one first, because what I'm going to do is I want to figure out which of these two fractions is bigger. And what I'm going to do is convert both of these numbers, the fraction and the decimal, to fractions over 100. Now, I said in the last piece of paper that if I were to multiply this, let's see, by a factor of 50, then I would get my equivalent fraction with a denominator of 100. So 1/2 converts to 50 over 100. For 0.43, all I need to do is just put it over 100 because the 3 is already in the hundredths place value. And so what I can see is that 1/2 is actually bigger than 0.43, because 50 over 100 is bigger than 43 over 100. Now this one's a bit trickier because this uses a improper fraction, and then this is a number that's greater than 1. And so what I can do is I can convert this to a number with a denominator, or sorry, from a improper fraction to a mixed number. So again, 3 over 2 converts to 1/2. Okay, and then I need to change it to a denominator with 10, because the 6 is in the tenths spot. So then I'm going to kind of squish it in here, but I'm going to basically multiply 1/2 by a factor of 5. So that's going to give me 1 and 5/10, because 5/10 is the equivalent fraction to 1/2. And then this is going to convert to 1, and 0.6 converts to 6/10. So 1.6 is equivalent to 1 and 6/10. 3/2 is equivalent to 1/2, which is equivalent to 1 and 5/10. So that means that 3/2 is equivalent to 1 and 5/10. Now, I can see that because the 6 here is larger than the 5, that 1 and 6/10 is bigger than 1 and 5/10. And then the last thing that would be here is to put these numbers in order from least to greatest. And I will let you do that on your own, which is going to be part of the practice in the workbook. So I thank you for listening again. I hope you guys have a great day, and I'll talk to you soon.